Okay, so I have 3 examples for you for all the cases that I'd like to work out. One is 7x plus 10 over 2x plus 3 times x plus 1. And here we assume we already factorized the denominator, and we know this is going to end up being something like a over 2x plus 3 plus b over x plus 1. And how do we now find a and b? Well, we multiply this partial fraction by x plus 1 over x plus 1, and we multiply this partial fraction by 2x plus 3 over 2x plus 3. So we get a over 2x plus 3 times x plus 1 over x plus 1, it's just a fancy way of multiplying by 1, plus b over x plus 1 times 2x plus 3 over 2x plus 3. And what we now have achieved is that this whole thing can be written as ax plus a plus 2bx plus 3b over 2x plus 3 times x plus 1, which is in the form of our initial expression. Now, the denominators are already equal. Now we just need to get the numerators equal. I will collect up the x's and the constant coefficients. So we have a plus 2b times x plus a plus 3b is equal to 7x plus 10. This gives us 2 equations, one where we look at the terms with an x, and one when we look at the constant term, and we can rewrite that as a plus 2b equals 7 and a plus 3b equals 10. Now if we subtract the first equation from the second equation, we'll get b equals 3, and if b equals 3, then a must equal 1. So we can put these answers in our original fractions. We get 1 and we get 3. So this is if we have distinct linear factors. Another form. If we have 10x plus 18 over 2x plus 3 squared. So now we don't have distinct linear factors, we have repeating linear factors. We will have to write that. Well, actually, let me take a different one. Sorry. Let me take x plus 2 over x minus 3 squared. It's going to be a bit easier on the board. So we still have repeating factors. We will rewrite that as a over x minus 3, and here we get that x minus 3 term squared. All right, well, how do we find this? Well, we can multiply left and right by x minus 3 squared, and then we get x plus 2 is equal to a times x plus 3 plus b times, plus b. So what I've done is I've multiplied the left side by the denominator. So we were let me just work that out completely. So we do x plus 2 over x minus 3 squared times x minus 3 squared is equal to a over x minus 3 times x minus 3 squared plus b over x minus 3 times, squared x minus 3 squared. And what we're left with is these two cancel out. Here we cancel out 1. and here these cancel out, plus b. And again, we have a certain amount of x. Let me just rewrite this. This is a times x minus 3a plus b is equal to a plus 2. We have our terms with x, and we have our constant term. We have two equations, two unknowns, and we get that 1 is equal to a and 2 is equal to minus 3a plus b. And if a is 1 here, then b is 5. And we can put those in here. 1 and 5. Well, the final example will be an example where we have a quadratic factor with complex roots, so one we will not be factorizing. So for example, 3x plus 1 over x squared plus x plus 10 times x minus 1. So we have two factors, and one of them is a quadratic form. If we look at what we call the discriminant, b squared minus 4a, then we know that's going to be negative, so we'll have complex roots, and we can rewrite this as ax plus b over our quadratic term plus c over our leftover linear term. We employ the same method by taking this and making it so that the denominator left and right is the same. So we multiply this term with x minus 1 over x minus 1. So we get ax plus b times x minus 1 over our denominator plus c times x squared plus x plus 10 over, over, well, x minus 1 times our quadratic one. I'll just write this one there. This together has to be equal to that one, so we know that the denominators are equal. Now we just focus on the numerators. And so ax plus b times x minus 1 plus c times x squared plus x plus 10 must equal 3x plus 1. And if we write this all out, we will get a plus c times x squared plus minus a plus b plus c x plus 10c minus b has to be equal to our 3x plus 1. The terms with x squared have to be equal to each other. The x squared terms, well, here we have no x squared term, so that will be 0. Our terms with an x have to be equal, and our constant terms also have to be equal. So here the blue term is 0x squared. So these three things have to be equal to each other, and what we find is that a plus c equals 0, minus a plus b plus c equals 3, and minus b plus 10c is equal to 1. And so we have three equations, three unknowns, and if we solve this, we can do this through substitution or any other method, we find that a is minus 1/3, b is 7/3, and c is 1/3. And we can put these in there and we will have our partial fraction expansion.